In my last class, we talked about the implementation of virtual functions using the virtual pointer and virtual table. And we found that how the classes are internally added with extra code, extra piece of code, and a separate table containing the pointers to the virtual functions, as well as every class object, which is a polymorphic object, will be added with a additional pointer, which is called the virtual pointer, and the virtual pointer will point to the virtual table corresponding to that class. At the same time, whenever we make a call to that virtual function through a base pointer or through a pointer to that object, we found that that normal call gets translated to something different, and we found how using the dereferencing we can actually invoke the suitable function depending on the object type. So in this class, we'll be mainly talking about more of a design issue, and at the same time its implementation. We'll be talking about abstract base class and pure virtual functions. So the idea is when we design a particular class, when we define the members of the class, virtual functions of the class, it might happen that the clear definition of that or the details definition of that virtual function, it may not be possible all the time. So in other words, in a particular base class, if you have defined, say, two virtual functions, one is f1 and another is f2, it might happen that in f1 you really is not sure that what will be the details of that function, how the function will look like, what it will do. It becomes difficult to define that function at that particular level, because we know higher up the hierarchy we are dealing with more generalized version of that particular class. The moment we go deeper down the hierarchy, we are trying to define specialized classes or subclass of that particular class. So what will be the specific kind of behavior of a particular function may not be clear in the higher base classes. Okay, so that creates that needs to define a virtual function as a pure virtual function. So let's talk about it in details. So let me share the screen. Okay. So in this class, we'll be talking about pure virtual functions and abstract base class. And the example, so before we get into the details of how this abstract base class need to be implemented, or how this pure virtual functions are to be actually implemented, let us take some class hierarchy examples which actually models the ISA relationship. So this is one that, again, the similar kind of examples we took while I tried to introduce inheritance. So here we see that employee is a class, but when we say in an organization we have got employees, it becomes very vague, because employees, if you look into the set of employees, those who work these days, in a broad sense, you can clearly distinguish between the permanent employees and the temporary employees. And temporary employees, they just have, in the salary component, they have a fixed salary, no breakups, no increments like that. So they negotiate with that kind of deal. I mean, they agree with that kind of deal, and that is how they continue. Whereas in case of permanent employees, you know that there are different components of the salary, the basic, DA, TA, HRA, and all this. And however, if you go into the details, like a permanent employee, if I say that what will be the salary, it will be difficult to say, because again, among the permanent employees, if you just consider the faculty as well as the administrative staff, So then they are having some additional, like you can think of like the administrative staffs, they are having the I mean the faculties, they have the PDA, and the administrative staff they don't have the PDA component like that. So what I mean to say is in the employee level, and I mean that every employee probably, I mean there may be other behavior or functions we define, but if we think that the employee will have a leave, or like apart from salary, like in this case the salary uh, may not be a important component here, because the temporary employees, their salary is trivial, it's a fixed value, but a display leave can be a good function to model this. And for employees, again, the display leave means number of leave days in a year that a particular employee can enjoy. Now when you say employee, how many days of leave, it's a very vague question, because if you think of those, again, those temporary employees, they just enjoy only the national holidays as well as the casual leave, maybe say 12 days in a year, apart from the holidays, national holidays and weekends. But if you come to the permanent employee, they will have national holidays, casual leaves, and medical leaves also, because as permanent employees you have got few number of medical leaves per year that gets accumulated. Okay, and at the same time, even among the permanent employees, if you are administrative staff and a faculty, you have got different, you will enjoy different kind of leave. So say for example, faculties, they generally enjoy vacations, both summer vacations, winter vacations and all. However, the administrative staff, they don't have vacations, rather you can think of those people enjoy lien, like they can take a short leave of say a year or two, and they can join somewhere else and again come back, so their job will be secure. So in that sense, again, if I go up to the generalized hierarchy of employee, if I simply ask number of leaves, number of days of annual leave that that employee, I don't know what kind of employee, just employee will enjoy, it becomes very difficult to answer. So the point is, but I know that employee, definitely leave is an important component to model an employee. So the designer, in such a case, when it defines the employee class, the designer knows that display leave is a very important method, important function that should be a part of it, but he's unable to define clearly the behavior or the details of that particular function, because it's a too generalized case where you could actually foresee or can pinpoint the details. However, if you go down, you will find that when you think of permanent employees or temporary employees, now permanent employees, like temporary employees, you know that national holidays and casual leaves, as I mentioned. But for permanent employees, there are three components: national holidays, medical leave, and CL. And there may be something else also, like there may be something else that again is not clear until unless you specify what kind of permanent employee it is. So here again, you may have got some idea of what will be here for permanent employees, so that they get distinguished from the temporary, but you cannot again uh, pinpoint the entire calculations till you know if it is an administrative staff or faculty. So what I mean to say is, when you are defining or modeling classes, or you are defining is a hierarchy among the classes, it might happen. It might happen that in the top uh, mm, uh, in the top order classes, the root based class or the intermediate based classes, there may be cases where some functions you don't have adequate knowledge at that level to define it. So those functions are definitely virtual, because those functions will be a part of the derived classes down the hierarchy. So those need to be declared as virtual, definitely. But those classes will not or may not have a definition. And I mean, even though they have a definition, so sometimes if they don't have a definition, so then probably those classes cannot have a particular instance created. Or in other words, you can think of, because employ few things you can visualize, but you cannot pinpoint. So you cannot expect that a employee object can be created, okay, or a permanent employee object can be created. So the point is, okay, there are some interruptions. Sorry. So, so the point is, as I mentioned, like higher above the class hierarchy, there may be the case that you are unable to clearly define or completely define a particular function, a virtual function. Those functions are called pure virtual functions. And uh, in that case, if some of the methods are not completely defined, you probably will not be able to create an instance of that class. And in that case, a class is called an abstract base class. That's the idea. And so the idea is a particular class at any point, at any particular level of the hierarchy, may be a abstract base class if one or more than one virtual methods of that class is a pure virtual method, where you just specify a name for that particular method, and you probably define the interface for that, like you basically declare the prototype for that particular function, but don't give any detailed specification. So later on in the next slide, we'll see that how to actually declare, implement or write such a function where you just have a name and, uh, and the input output arguments, but don't have the body. Okay. And if we run, we see that if you try to create an instance, it will give error messages. So there can be some few more examples that we can take before we get into the implementation details. So this is one more where you have got a transport mode, and the transport and there can be different transport modes like air, road, and train. And the air can be commercial plane, chartered plane, or a copter. In the road, you can think of having a private car, rented car, or a bus, and otherwise it can be a train. Like and the idea can be like in the transport mode, you will have data members where you accept the source and the destination. And if you give a source and destination, you probably will be interested to know or calculate these functions, like calculate the expenses to travel from the source to destination and the total travel duration in between that source destination pair, as well as the capacity, like how many persons can travel at most. Okay. So here, if I just have, I know that no matter what kind of, what mode of transport you choose, or the, like air, road, or train, and a specific air mode, uh, air travel mode, or road travel mode, irrespective of whatever you do, these three are more or less common that we expect to be there. Okay, so in the transport mode itself, we know no matter what the specialized transport mode you have, but in general, any transport mode must have these three functions. So you know the functions, you probably know that what will be the input output arguments, and everything is clear. But what you don't know is how much the expenses will be, because if you think of air travel through commercial plane, the charges that you have to pay for a particular travel of say 2,000 miles sorry, will be different from a chartered plane or a copter, because there are different fare components that you have got here. In the road travel also, if you have got a private car, you can hire a driver, and that much, as well as a fuel charge you have to pay. If you have rented car, you have to pay for hiring that vehicle also. And if you are traveling by a bus, you just have to pay a nominal charge probably. So in that way, that the components of the expenses that you have to incur differs, as so the calculations also will differ, and that will not be clear here in this top level. Travel duration also, it will differ, on the speed and different other, like how many hops you have to take, stops that you have to take, and all. The capacity also will vary across the different specific type. So here also, when you think of implementing the transport mode class, you will find that these are the classes, these are the functions which are need to be labeled as virtual, because they also will be a part of the derived classes and down the hierarchy. But these need to be defined as pure virtual classes, where they will have some interface but not having any specific definition, because of lack of proper information, and it's not possible to define that. This example, we have got the shapes, and shapes is a very generic concept, because shape can be again polygon type, it can be closed conics which has got curve like shapes. Polygon type shapes may be triangle, quadrilateral, and then again quadrilateral can be of different types, square, rectangle, and all. So like that it can go on. And the closed conics can be again elliptical or circular, like this. So in the shapes, probably if you think of defining a shape class, we will be interested to draw the shape, as well as we will be interested to calculate the area. But just telling about shapes, it is difficult to find out what will be the how to calculate the area, because shape is just specifying shape is too vague to get into some calculations, as well as the drawing logic also cannot be defined. But if you come to this point, polygon, probably you can have some idea of how to draw, like join those points and using a straight line and all. But closed conics, this may be still not possible, because until unless you say it's a circle or an ellipse. And circle, we have got Bresenham's algorithm. For ellipse, we have got different kind of algorithms. So the actual technique of drawing a particular shape depends very much on what specific shape you are specifying. Even closed conics, specifying it as closed conic may not be enough. In case of polygon, there may be having some similarities like that. So the point is, an area calculation also cannot be done until unless you come to this level. So in this hierarchy also, you will have enough idea of what methods will be there, what virtual methods will be there, functions will be there, but you don't have enough information to define them. So here they will be declared as pure virtual functions, as well as uh, and because of that reason, these classes cannot have a instance or object instance, because things are not yet complete. Okay, so those classes, this shapes class, transport mode class, or even the air road, these classes will then be called as abstract base class. These are base classes, but these are abstract base class, as you are not able to create an instance of that base class. Now, so the idea is the base class. Earlier we found A or B. B is a base class, D is a derived class. So we have been able to create an instance of base class and also of derived class. But here, in contrast, here the base classes or some base classes may not have a complete definition of their functions, and because of that they are abstract. We call it abstract base class, and they cannot have an instance, object instance also. Okay, and finally this list, it is again trivial. List is too vague, you don't know what to do, but you know that lists we can insert, we can delete elements, and we can display the list. But the display list is generally a one-dimensional list you can think of, and displaying is just start from one end and just keep on traversing and displaying the values. So the display mode is trivial, no matter how the insertion can take place, what are the restrictions. So the display is fine, but these two are incomplete. This is complete. And the insert, if it is list, it can be a stack type or it can be a queue type. So queue is a list, stack is a list. Each of them, they have their own insertion deletion rules that they have got. And a queue, it has a DQ is a queue where you allow insertion deletion from both ends. So here in the topmost level, you just know insertion should be there, because lists, these are the basic operations that you would like to perform on list, but you don't know what will be the type, how you actually can insert until unless you specify uh, the actual data structure, that it will be maintained as a stack or a queue or DQ, whatever. Okay. So to summarize from these examples, the root base class or the classes like this up the hierarchy can identify few common functionality, and this functionality is called interface, which need to be included within the specialized classes derived from from it down the hierarchy. So if they cannot define it, why do they mention? Just to make sure that when the derived classes are derived are created from that base class, they should so they are given some footprint, some kind of blueprint of what kind of methods should be there, and their task is just to fill up the details of it. So in such sense, these classes, abstract based classes, provide the interface of how provide a common interface that all the derived classes should follow, which will be created out of it, created from it. But again, as you know, the derived classes can have some additional functions also apart from the common functionality. And here we have marked in red those methods, or at a particular level, if the method is incomplete or cannot be known, then we have marked it as red. And in such cases, these base class functions will then typically contain just a declaration without a definition, and these are called pure virtual functions. And the base classes having at least one pure virtual function, or maybe more than one also, will be called as abstract base class. And the pure virtual function bodies are supposed to be defined. Now somebody has to define it, otherwise that remains incomplete. So it is expected that when you inherit some class from that base class, at some level you implement the details of that function, so that now you can create an instance of that particular class. Okay, so in some sense, in contrast to the abstract base class, a class which don't have any pure virtual functions, where all the virtual functions are having some definitions, either inherited or they have done of their own, they are called concrete base class. So you can think of till now the base classes or classes that we have defined were not abstract, so they can be called as concrete base class. But now in the next slide we'll find that we'll just highlight these points that we just now mentioned, and we'll go and take some examples or implementation of it. So a pure virtual function is a virtual function that typically have a declaration or signature and no implementation. Hence, it is required to be implemented by the derived class down its hierarchy, which inherits it. Then a class containing at least one pure virtual function is called as abstract base class, does not necessarily provide implementation. Now, this is important to note, does not necessarily provide. So the point is, abstract base class, it may not have any idea of what to do, or it may have some bit of idea, but that is not complete. So what I mean to say is, when we think of virtual functions to be defined in the base class or in the abstract base class, what we say that we may not have any idea, but sometimes we have got some idea, but that is not incomplete idea. So sometimes you write some body in the pure virtual function, we'll see how, but that definition, whatever you write, is not complete, but you are capable of writing something on it instead of just writing the signature. Okay, so that's why I said does not necessarily provide implementation. But it may provide some implementation, and still it can be defined as a pure virtual function. But this is for sure that no instance can be created for a abstract base class which has got pure virtual functions. And because of that, these abstract base classes will have no constructors and destructors. Okay, but then what is the use of it? So they are use it just to create that hierarchy where you give the common interface, you define the common interface to be followed by the derived classes. And the abstract base class may have non-pure virtual functions or pure virtual methods, so it can be a mix of both in that. And the data members in abstract base class, generally they should be protected. However, they can be public or private. And member functions in abstract base class should be public. However, they may be private and protected. So these are kind of recommendations that data members in abstract base class uh, should be protected. Does not necessarily mean that they should be always protected, and member function should be public. And finally, as we mentioned, a concrete class is a class where which actually overrides any of the pure virtual function that its base class has defined, and this class itself cannot create or will not have any newly created app pure virtual functions. Okay, so nothing is undefined here. Its complete definitions are there, so that we can create instances of such classes. So that's why we call it's a concrete class. So in the next slide, I'll take the examples of. So one example, and we try to implement something similar to that of class hierarchy. And we have got employee, permanent, temporary, and staff and faculty. And we just restrict ourselves to implementing, or kind of having some implementation of the display leave. And to be specific, we are not actually doing the calculations here. Within each method, as we defined, we have a prompt just to say that these are the different components of the display leave. So here what we have is, it's a class employee. So I'm defining this class, the topmost class. And here what we find, there can be a data member also. So we are trying to define abstract base class, because as I mentioned, employee, at that level we don't have sufficient details, and we are unable to define the details. But still, we know that no matter is a permanent, temporary, staff, faculty, whatever, the employee ID should be there. So I can specify the data member, which will be after all inherited in the lower level hierarchies also. And the virtual void display leave, now you see the syntax of it. So display leave, it's going to be a you define it as a pure virtual function. So I write display leave, it's not accepting anything, it's void, and returning void we have defined as virtual, but this is a point, this equal to 0. Equal to 0 means it's not completely defined, you can think of. So equal to 0 means this is a virtual function which is of pure sense, pure in the sense, in this case this is incomplete. Okay, and at this point, as you can see, it's not only incomplete, it's not having any definition. So that is generally that happens. So you cannot define anything of that. Now when you then we try to define the permanent class, which is again a base class for with respect to the staff and faculty. So it's an intermediate base class, it's a root based class. So and because this employee class is having a pure virtual function, it is acting as an abstract base class, and you cannot create an object of employee class. Now class permanent, as you can see, we have not explicitly defined any method or function for this. However, because it has been inherited publicly, or is a relationship, it has inherited this display leave function here also, as again as a pure virtual function. Now as we found that at this point, permanent class also, we cannot complete the definition of that display leave, because again it depends on if it's a staff or faculties. Faculties will have vacational leave, staff will have the lien kind of leave, apart from EL, medical, national holidays, and casual leave. So although these four are common, we can know, but there are few other components which cannot be known till you get down to the hierarchy. So that's why we have preferred not to specify anything, and it just inherits that pure virtual function, does nothing. As a result, it becomes an abstract based class, and no instance can be created. So after that, we try to define the temporary class, and the temporary class is again another it's a derived class. Now the temporary class deals with the display leave or the employees who are all temporary, and maybe that no matter what kind of employee that person is, their leaves are quite well defined. So like the temporary employee he can be a temporary faculty, or he can be a temporary office staff, whatever, doesn't matter. So temporary staffs, they all have just national holidays and casual leaves, and that does not depend specialization of that temporary staff, I mean the category of that temporary staff. So this ends up here, I mean the hierarchy at this level ends, at this branch ends up here. So because we are, we now have a clear picture and clearly we know what it is, so here we clearly define, or you can think of, we actually, it's not redefinition but just definition, we define this value. And here we write temporary staff, that means we try to specify what kind of staff it is, and we mention the different components, CL, national holidays, like that. So you actually don't do any computation, we just specify the components of the leave that the employee will enjoy. Then if we come to the staff, as you can see, so in that staff we have got a display leave, and here now we have got a clear idea of what kind of components it will be there. So the display leave, here we know that these are the 5 components, so we just specify all the 5 components here. Okay, so earned leave, medical leave, casual leave, national leave, like this. And okay, so the staff will have these 4, and it will also have the lien part. Okay, and that we have found, so maybe the lien part also can be added. And the faculty will have all these 4, in addition to that we'll have the vacational leave, like this, and the faculty is implemented. So faculty is a permanent employee, staff is a permanent employee, so they are inherited from this temporary class, and accordingly we have defined their display leave. Now in the main function, if we would like to, so this class hierarchy has been created. So if we would like to create object of employee type and a permanent type, then what happens? So employee type object, you see, as we mentioned, these are abstract base classes, and because of that this employee type object cannot be created here. Okay, so if I try to do that, it will give an error message, cannot declare variable A to be of abstract type employee, and permanent B also, it will say that it cannot create a variable of type B because it's abstract type. So this is fine, because we know that the methods, although they are there, the methods, the details of the method is not there. So even if you create an instance, if you invoke that method or function, you don't know what to do. So that's why these are not allowed. Now we do something interesting. We just create here, as you can see, an array of pointers, to employee class. That's the topmost base class. So we know that upcasting is allowed. So we would like to store the objects or the addresses to the objects of different types of employees. And say for example, in a particular department or in a particular say office, we like academic department, we have got 2 faculties, 2 staffs, like administrative staffs, and 1 temporary staff. And we would like to have in the payroll, we would like to have the information of all these 5 employees, 2 faculties, 2 administrative staff, and 1 temporary staff. Now the point is, now they are of different types, like staff and faculty are of different and different. But we know that if we can create a array of base type, the topmost base type or the root base type, that is employee type, the array of employee type class, then because of upcasting, if we have created a temporary object, we can store the address of that object in a particular element of that array. If you have created a faculty object also, we can upcast and store the address of that faculty object in this particular base pointer array, as well as for the staff. So we can think of that this employee array is basically a generalized container which can contain any specific instance below that hierarchy, below that particular base class. So if this is a base class, so it can store, by the virtue of that upcasting, it can store any type of object which belongs to derived class, which belongs to a class derived from that base class. Okay, so here, so this acts the generalized container. You don't have to define a different type of pointer to store that, and that is a nice thing. So if we have done that, so here what we did, new faculty means a new faculty object is created in the heap segment, and that object's address is stored in A0, ARR0. The second faculty also has been allocated dynamically. Its address is in ARR1. The first staff and the second staff in that. Okay, so ARR0, 1, 2, 3, 4, like that. It will contain the different objects of different types under that hierarchy. Now, if I write this one now, like for int equals to this, I equals to this and this, that means I'm trying to find out the number of elements in that array, to the size of ARR and size of employee star. So this gives you the size of this array. It will be 5. So for each of the 5 members, say I'm accessing the elements 0, 1, 2, 3, and what I'm writing, cout employee I plus 1 means the first employee, second employee. We could have specified the employee ID also here. Okay, maybe there may be some constructors which would have initialized this employee ID also. So this is trivial. Now here what we do, ARRI in that means the ith element of that pointer array will be invoking the corresponding display leaf. So through that I am trying to invoke the display leaf function. So what is display leaf? As you can see here, the display leaf has been defined as virtual in the base class, and that remains virtual in the permanent, temporary, staff, faculty, everywhere. Okay, so this is a virtual function, and ARRI is a base pointer. So through the base pointer I'm invoking a virtual function. It's a kind of dynamic binding or dynamic dispatch, and here the rule says the display leaf, as you can see, the display leaf has been defined in each of the classes, and also it has been defined in abstract form in the base classes also. But here, because it is dynamic dispatch, dynamic binding, this base pointer will find out what type of object it is pointing. It may be a faculty object, maybe a staff object, or it may be a temporary object. So depending on that, it will trigger the display leaf function to display either this or this. So that is a nice thing. And if we have executed this code, you find that employee 1, which is a permanent faculty, will have these leaf parameters. The permanent staff, administrative staff, will have these parameters. Again, the lien can be, you can add the lien here. Okay, and here also the lien type of leaf. And finally, the temporary staff will be like the national holiday and casual leave. Okay, so here in this particular slide, what we found is the syntax of defining a pure virtual function, that is this. And also we found that how this pure virtual function definition inherits in the derived classes also. And if you have not defined in a concrete class the definition of these pure virtual functions, you cannot create an instance of that. However, we can create generalized, and the interesting thing is we can create generalized containers for that, like an array of or a collection of objects, object pointers, which can point to different type of objects. And this is what we start feeling the advantage of polymorphism. So you don't have to, so just creating a simple base pointer type container, it can not only store but also accordingly and quite intelligently it can trigger the specific display leaf function which is matching to that of the object type. And this is what polymorphic nature is. So the pointer type in a polymorphic way, it can choose the suitable method or function corresponding to the object's type. So this is how the polymorphism is exhibited by the base class pointer type. Okay, and that's why the base class or all these classes in that hierarchy, these are called polymorphic class types, and the instances that we create, these class instances or objects, these are also polymorphic objects. And as we know from our previous lecture that all these classes will have virtual pointers, the objects will have a virtual pointer, each class will have a single virtual table that all the virtual pointers of the objects will be sharing or accessing. So the last slide will be just to have a small bit of information, like the pure virtual function, as we found as we found here, that it generally will have no idea of how to implement, or the definition is it's not known. But it might happen, as in this case, in the employee, that no matter what the employee is, earlier we said that we don't know, but that is also not true. You see that no matter what the employee type is, this national holidays and CL, casual leave, is always a part of it. But if you think of a permanent employee, they will have something more, like the earned leave and the medical leave will be added to this. And if you have got a staff, so they will have EL, medical, national. And so in each of this level of the hierarchy, even in the topmost hierarchy also, it is not that you know nothing, but you say what you know is a part of that. So you say that I know this much, but I am not sure that whether some more components will be, but these two components is definitely there. So when I define this or write this class employee class, we write like this. It is all the same. I write virtual void display. So this part is all the same. It is a pure virtual function because of this equal to 0. It makes it pure virtual. However, after this class definition, I just try to declare, or define the partial knowledge of that. What is that? I write display leave, which is a part of the employee, will have this body. So defining the body of the pure virtual function. And that is not very common, but again, this may happen. So a pure virtual function may have a body, and having a body of a pure virtual function does not mean that this is a complete definition. Whatever we know we have encoded, but there is something more for a concrete instance of an employee class. So this is there, but this is not complete. That's why I still make it pure. And because it is pure virtual function, the base class employee is still the abstract base class. Okay. So in this level also, instead of leaving it as blank, we know that, okay, definitely when you implement the class permanent from the employee as public inheritance, we know that this gets inherited from its base class as a pure virtual function. But here again, we would add a bit more information that we have got in this level, that earned leave and medical leave will also be there. Now what it will, so outside, after completing the class definition, I again write display leave corresponding to the permanent class will be defined, but again incompletely. So this definition does not mean that you have got a complete definition, but whatever I have got, I want to incorporate. So see out earned leave, medical leave, and then what I do, I know that apart from this, the rest of it, like whatever has been defined in the base class, the employee class, will also be a part of it. So I just call employee dot display leave. Okay, so that means I have this part as well as I add some more to it. So I'm just trying to redefine it, although it is incomplete. So definition of the body of the pure virtual function, here also I'm trying to define it. Okay, so in that way I keep on doing things. And then the class temporary, so I have got this one, I have got this one. And when I go for class temporary, now I find that temporary have got nothing more to specify, so it just completes, but however it need to complete uh, the pure virtual function. It need to define it without this equal to 0. So it says that this is the definition, and it says that it just gives a prompt temporary stuff and just calls employees display leave, because it has got nothing else to add into it. Okay, so this is done. Now we come to the staff, and the staff will find that all that has been defined in the higher above classes, higher above base classes will be there, like permanent display leave is there, and the permanent display leave will make use of the employees display leave. But additionally, it will have, uh, in this case, I mean, here I have not added lien, but you can add here lien. So lien part is missing. Later on I thought of adding it. So this lien part can be added. And this faculty, when you define the faculty class, you add the vacation leave. Okay, so once these are defined, what we see is the pure virtual functions here can have definitions, and if in case we have to define, we have to complete the class definition, and then only we can write it using the scope resolution. We write whatever we want. However, still they remain abstract, and the proof is like, if I want to create instances for that employee or permanent, it gives an error message. However, if I create a generalized container class and try to access it, this can be accessed, and the results are all the same. So the only difference that we make is, if we know something that is common to all these hierarchy, all these derived hierarchy classes, the topmost base class or the intermediate base class can define that portion in a pure virtual function that still remains pure, okay, through this equal to 0, like this. So pure virtual functions can have definitions, and abstract base class is a class which will have pure virtual functions, may or may not having definitions. We have taken the example of employee class hierarchy. So this completes the discussion on pure virtual functions and abstract base class. In the next class, we'll be talking about multiple inheritance.